Electrostatics. Nice. Electrostatics is a study of stationary electric charge. That's what this unit's about. All right, so Unit 8. We're going to start with electrostatics, then we'll work into magnetism. The reason why is a lot of people think electricity and magnetism go hand in hand, but they really don't.
This seems hard.
Okay. Electricity electric charges don't inherently have a magnetic field. They can create one, but they don't inherently have one. And that's something we'll get into later. Skylar, good question? Terry, got a question? Okay, so what are we talking? Okay. All right.
Are you recording?
Yeah, recording.
Why is it down so low?
What?
Why is it down so low?
What?
The low camera.
Oh, because I'm when you film the electroscope.
Oh.
And that'll make it easier.
You should try rapping in one of your videos and see how many views you get. Rapping
The rapping physics.
I'll probably get just as many as I usually get.
What if it goes viral?
Unless it goes viral, then you get 100,000.
All right, guys.
Then you have other physics class.
Hey, I'll wait until like 15 or 20 years from now I can use them there.
Or wait, Rich, you could download that app. It's like a rapping app, and you just speak into it, and it like corrects bad rapping.
Yeah. You mean the Little Wayne acting, the Little Wayne app? Because I think he uses it. All right, guys.
No, you need to get Talking Tom. That's how you should teach.
Guys, yes, we're taking notes. Okay. So, electrostatics. We're going to start with what we know about electric charge. Now, what is everything made up of?
Neutrons.
Atoms. Good. Now the atoms is a good place to start when we're talking about electric charge because an atom is made up of what? Neutrons.
Protons.
Protons and
Electrons.
electrons. Good.
Chemistry
So
came in handy.
an atom has protons in the middle along with neutrons.
What's a thread made out?
Electrons.
Love.
Millions of protons and electrons. Okay. So that's essentially an atom, right? What atom is this?
A big one.
Hydrogen, because we have one proton and one electron, right? Now, if I start adding protons, to this atom, what happens to the atom? It gets bigger and it becomes a new element. If I add one proton, this becomes helium. If I add another proton, it becomes lithium. If I add another proton, it becomes beryllium. And we'll stop there because I did a 6th grade project on beryllium. All right, so if I have 4 protons in the middle, how many electrons do we have around the outside? 4. Now, the interesting thing about chemistry is these electrons don't all sit in the same radius. They all have different energy levels based on the energy level. We can figure out how many electrons are there. So the first energy level has 2, then 8, and goes on from there. And that's where physics and chemistry overlaps because why they're at each energy level is quantum mechanics. But we won't get into
This
it
is a
now.
recap of one of our chapters.
Nice. Sweet. Do they conserve momentum?
Yeah.
Yes, they do. Every collision conserves momentum. All right. So here's an atom of beryllium. Okay. Now there are 2, or how many types of charge can beryllium have? There's a hint on the board. There's 2 types of charge, right? What are the 2 types of charge I can have beryllium have?
Negative and positive.
Good. It can be positively charged. Or it can be negatively charged. And there's a third state of being, which I don't consider my 2 types of charge, but you might think I'm being incorrect here. What is it, Katrina?
Neutrally charged.
Neutrally charged. Okay. I don't think neutrally charged is a type of charge, and just like neutral or negative and positive, I think these are more states of being than they are types of charge. Okay. But they come from the 2 types of charges, positive and negative. Yes.
I was just going to ask you, you were counting, right?
No, I am. Because there's only 2 types of charge, positive and negative, and how those positive and negatives interact create different states. Okay, we have a positively charged state, a negatively charged state, or a neutrally charged state. But these come from the 2 types of charge. So maybe if I do this, will that make you feel better, Skylar?
Just a bit.
Okay, we can put a little plus and a minus. Right? What's positively charged?
Protons.
What's negatively charged?
Electrons.
Electrons. Which one is allowed to move?
Electrons.
Electrons. Okay? So when we're talking about these different states of charge, either positively charged, negatively charged, or neutrally charged, the only charge that's allowed to move is the electrons. Okay? Electrons are the only ones allowed to move. Alright? So, what? You said something. What'd you say?
I said I hate chem.
Oh, you hate chem.
That
Well,
probably
this is
makes
as
me
far as
feel
we're gonna get.
Yeah.
All right. All right. So positively charged. That means we have an abundance of
Protons.
Electrons.
protons. You have abundance of positive charges, right? Those of you that take chemistry, you know that beryllium makes a cation when it loses 2 electrons, right?
So it's a plus 2.
When it loses 2 electrons, it becomes beryllium plus 2.
Yeah.
It has a net charge of
2.
positive 2, right? Because we have more positives than negatives. So positively charged means you have more positives than negatives. Now, from here going forward, I'm going to use a plus sign for positives and a minus sign for negatives.
What do you use for neutral?
Neutral. Yeah. All right. So if I'm negatively charged, then that means what?
More electrons than protons.
Good. More electrons than protons, or more negatives than positives. Right? Beryllium is not an element that will gain electrons. Those are the anions. They're on the other side of the periodic table. Oxygen is one that will gain electrons. Oxygen has 8 protons. It'll gain 2 electrons. If I have 8 protons and 10 electrons, then what's my overall charge?
-2.
-2. All right. So by gaining electrons, we become negative. By losing electrons, we become positive. Okay. So positive charge means we lost negative charges. Right? Negatively charged means we gained negative charges. And the reason why we either lose negatives or gain negatives is because electrons are the only charges that are allowed to move. Protons are stuck in the middle. Alright? Protons are stationary, electrons can flow. What does neutrally charged mean?
When electrons and protons are equal.
Okay, good. We have an equal number of positives and negative charge. Okay. So beryllium that beryllium atom I have drawn, that is neutrally charged because we have an equal number of
Electrons and protons.
good, equal number of electrons and protons. Positive and negative charge ratio. Now, yesterday you guys did some electrostatic investigations with the comb and the confetti, with the rod and the salt, with 2 balloons, with the balloon and the pop can. Right? Now, in every one of those situations, you cause something to move, whether it's the 2 balloons, you cause the 2 balloons to they go together or push apart. The 2 balloons, did they come together or they push apart? They push apart, you cause them to repel each other, right? Okay. Why do the 2 balloons repel each other?
They're both negative.
Okay. They both have the same charge, right? Now, when I brought the balloon next to the pop can wanted to go with the balloon, right? When we brought the comb next to the confetti all jumped to the comb, right?
Because they have.
When I brought the rod next to the salt all jumped on the rod, right? Because they were
Opposites.
good. They were opposite charges that were attracted, right? So one thing we need to make note of is that with these charges,
Opposites attract.
opposites attract. And likes repel. Now something else you may have noticed. Because was the confetti charged when you brought the comb next to it?
I don't know.
No. Was the salt charged when I brought the rod next to it? No. So what do you know about neutral? It does not do it. Neutral does something. Neutral is attracted to both. Okay? Because the pop can was neutrally charged. You brought the balloon next to the pop can, wanted to go with the balloon. Right? So neutral is attracted to both.
So how do you give something negative?
We will get there.
I know. I brought my own tape.
if I'm neutrally charged, I'm going to draw a neutrally charged balloon. There's my neutrally charged balloon. How do I know it's neutrally charged? Okay. Has three positive charges, 3 negative charges, right? Right? If I'm negatively charged, what does that mean? We gain negatives or do we lose positives? We do not lose positives, we gain negatives. Okay. So we still have 3 positive charges, we just have more negative charges. Okay. So now I have 5 negatives and 3 positives, we have a negative charge. Right? If my balloon is positively charged, what does that mean?
Less negatives.
Good. We have less negatives. So there's my 3 positives, and let's say I have 1 negative. Okay? So here's my neutral balloon that I started with. Here's the neutral balloon gaining. I have 3, yeah. Gaining 2 electrons. Right? And here's the neutral balloon losing 2 electrons. Right? Does that make sense?
Yes.
Okay. Now keep that in your mind. We do not gain positives. We lose negatives. Okay? We don't lose positives. We gain negatives. Because negatives are the only thing that can move. Okay? So,
What's that thing? It's like a wave of
Rex asked the question,
electron.
how can something gain charge?
Sea of electrons.
Well, first, those are metals, right? Metals have a sea of electrons, and that's why they conduct electricity, because the electrons can move.
Flow freely.
Okay. So here I have a picture of our electroscope, right? I have it projected on the screen so all you can see it as well. Right? Now what I'm going to do is I'm going to charge this electroscope. Sorry, I'm not going to charge the electroscope. I'm going to bring a charged rod near the electroscope, and then maybe you guys can figure out what an electroscope does.
How come the black one was
So-
better than the
Are you trying to get a
So here we go. Charged rod. How do I charge it?
Not rubbing it.
Okay. I rub the rod with the wool cloth. Now this rod is rubber, so it's a lot like a nope. So it is an insulator, but it's a lot like a balloon, right? Balloons are rubber, aren't they? Okay. This wool cloth is a lot like people's hair. Yeah, it's got a bunch of little fibers in it. So this is simulating rubbing a balloon on your hair. Okay. Now what's happening is the rubber has a strong electron affinity. What does electron affinity mean? It wants electrons, right? Affinity means likes. It wants electrons. So when I'm rubbing the rod with the wool, what's happening is I'm giving this electrons. So what's the charge on this?
That's negative.
Negative. Okay. So I'm gonna bring it close to my electroscope. You guys see the leaves?
Starts to spin.
Nothing spins. Okay. I didn't want to do that. So, I'm going to bring this rod close to my electroscope, and what do you guys notice that's happening?
It's separated.
What's happening with the leaves?
They're pushing apart.
They're pushing apart. Why are they pushing apart?
Because they're both hot.
They're both the same.
Jesus.
They don't like each other and they don't want to be near.
So, an electroscope,
They both stink.
There was no love going on.
an electroscope is an object that stores, or sorry, that measures. Well, this is gonna be really tough to read for those watching. Measures electric
We're videotaping?
charge. Yep.
Oh.
Okay. So an electroscope measures electric charge. Okay. It measures electric charge by how much the leaves spread apart. Okay. So the electroscope started like this. Easy way to draw an electroscope: just draw a little sphere on top, a straight line down, a crossbar, and then 2 parts that hang down. These 2 parts that hang down, they're called the leaves. They're usually made of aluminum foil because aluminum is a conductor. Conductors let electrons flow. The electrons move, right?
Sea of electrons.
Now, when this is sea of electrons, any way you can get in there, right? When this is neutrally charged, that means we have an equal number of
Electrons and
Particles.
positives and negative charges. Electrons and protons, fine. We have an equal number of positive and negative charges, right? Okay. Now, when we bring a negative rod near the electroscope, okay, we started like this. We start like this, right? We bring the negative rod near the electroscope. What happens to the negatives? Do they like each other? No. So, do these negatives want to stay up there?
No.
Where do they go?
No.
They move. So, the negatives from the top of the electroscope run away from that negative charge and they redistribute. They redistribute down in the leaves. Then the leaves get an overall negative charge, and what happens to them?
They separate apart.
They separate. Let's Miss Branch. Come on. I know we gotta fix it. Yep.
Why don't we do breakfast?
Tomorrow.
Is everybody gonna remember what they're bringing?
Okay.
Or do you want me to send like a picture?
So there's the electroscope. So now what happens to these leaves? Do they stay like that? No. The leaves feel a force outward because the negative charges, do they like each other? No. The negative charges don't like each other, so our leaves end up looking like this.
Think like a proton, always positive.
Remember we saw that?
So there's an abundance of negative charge because they're fleeing the negatively charged rod. Does that make sense, guys? Guys, does that make sense? Any questions?
So right now they're still pushing away from each other.
Yep. Well, mine aren't because I don't have the negative rod, the actual one. But this one does.
But on the left side, it's still 4 negatives. Oh, because they're equal.
Right. So we have equal charge. So there's just as many negatives as there are positives in the leaves. So they're not pushing away. They're okay. They're like there's no force being applied. But then once this negative rod gets brought close, the electrons flee, and now each leaf has an overwhelming negative charge.
Okay.
So then they push apart. They repel. Does that make sense?
Yeah.
Any questions, guys? Okay. And it all goes back to like charges repelling each other. Okay. Now, if I take that rod away, now in your notes, don't erase this. Okay. Maybe like draw another electroscope and then draw another picture. Okay. If instead of using a negative rod, we use a positive rod. So here's the neutral starting. Okay. Instead we bring a positive rod. Omar, what'd you say? They'll go together.
Will they? Will they really?
I don't know, I guess.
What do you guys think?
Wait, what's the thing?
We're going to
We'll go
instead
like
bring
this.
a negative charge.
Like this.
So Skylar's saying he thinks the leaves are going to do this.
But you can't add a
Oh,
positive.
you're gonna bring a positive.
How do you do that?
You can't add a positive.
I don't think it's gonna
Well, first, let me prove to you that I have two different charge rods. This is how I'll prove to you. Okay, everybody see our electroscope?
Yes.
So you're gonna take the clock instead of the
Where's the others?
18 minutes.
So, here is the negatively charged rubber rod, right? I'm trying to see a little more perspective so you can see the shininess.
That's actually better. Or that one.
Did I go this way instead?
Yeah.
Okay. Alright, so, here we go. Negatively charged, right? I'm going to do this. What am I doing now?
Yeah, bringing it in and out.
Nope.
electrons.
I left electrons there, right? I've left electrons on the electroscope. And we can see because the leaves are spread out, right?
Yeah.
So that means there's more negative charges there. Does that make sense?
Yeah.
Okay. Now I'm going to bring this glass rod, which I'm rubbing with silk. Okay? What happens?
Put it back.
Okay.
Oh my
The
gosh.
leaves go back in,
Leaves
which
it
tells me that the glass rod has what charge?
Positive.
Positive.
Leaves
Okay.
a lot of electrons.
So, the question is, see, now I just took the electrons away because I am a conductor, which is why I'm afraid of lightning. Okay? Alright? I just took the electrons away. Okay? So the question is, what's going to happen when I bring the positive glass rod near the electroscope?
It's gonna take.
Okay, Omar said go together, Skylar said go together, Rex said go together. Who thinks the leaves will go together? Who thinks the leaves will do nothing?
Who doesn't know?
Who thinks the leaves will spread apart? Who doesn't know? Wonderful, I appreciate honesty. So, more of you voted for the leaves will go together, right? Okay. Prepare to be amazed.
Whoa.
You guys ready? Take a positive charge on this rod.
Hey, I like it.
Whoa! You see it?
Oh, I know.
Whoa! Leaves go apart. So to an early physicist studying this, you might think that the glass rod and the rubber rod have the exact same charge. Right? If I would have just brought them both by each other, you wouldn't believe me they were different charges because they cause the same what? Reaction. They cause the same result. The leaves spread apart, right? But when I showed you when I charged the electroscope negative and I brought the glass rod by it, the leaves got close together. So what's happening? Right? That's a great question. Okay? So if I look at my neutrally charged electroscope with a positive rod coming near it, what's happening? Who doesn't like positive? Positive. So all the positives run to the bottom, right?
Okay.
What'd you say, Sandra? Louder. It's right. Say it louder. They don't move. The positives don't move.
Because they can't move.
They can't move. So who moves?
Electrons.
The negatives. The negatives down here say, well, there's positives up there. Let's go.
Bryce is trying to prove
Okay? It's like when I take a pizza and put it in the cafeteria. Kids run.
So excited.
Right? The electrons run to the positive charge. Okay?
yes.
They like the positive charge. So all these electrons from down here, they don't care that there's electrons up there. All they see is that positive charge. So the electrons all run up there. So then what's left down here?
No electrons.
Just positive. So what do these leaves do?
They repel.
They repel.
Wow.
They feel forces this way, which results in the leaves doing that.
I have a question.
So you get the same results, two different ways. Okay, what's your question?
What's your favorite unit to teach?
Physics?
Yeah.
All of it.
Oh my
You
god.
can't pick.
You don't have
I
most
can't pick
favorite.
all of it.
Most favorite.
Most favorite, like we just love teaching it.
It's like picking your favorite food.
What?
Take all your
can't.
favorite food and you get to pick one of the food. Which one would you
There's a reason why I'm still dealing with an overweight childhood. Okay? I like all foods.
You're a baddie.
I was.
Did you go to bed?
I can imagine him being fat.
I was under 5 feet tall and I was 200 pounds.
You had like a chubby face, no
Whoa!
When I was a freshman. I weighed the
You guys
same
have
amount.
a picture?
Holy crap!
When
You
I
were
was the
under
same amount
5
when
feet
I was a
when you were a
Show us a
freshman.
picture.
I don't have anything with me.
No,
Later on.
but like, can you bring it tomorrow or Monday?
What?
He reminds me of the guy from Diamond. Can you bring it tomorrow so we have entertainment while we eat breakfast?
I won't be here tomorrow.
You
No. Can you email it to Mr. Dyer?
Okay. Charge electroscope. Okay. I move my electroscope. Camera. You gotta pop the camera. We already talked about it.
No, we didn't.
But we changed days, so now
We
we're
don't know
all
which
confused.
day.
Alright, we have time left, we can talk about it. Alright, so a charge electroscope. Alright. So, Rex, you had a question of how do I charge an electroscope?
Let's get the first.
Well, there's two ways. Oh, you gotta do that. There's two ways I can charge an electroscope. Right? One way I can charge an electroscope is by conduction. What does conduction mean?
We know electrons.
What does conduction mean? Guys, what does conduction mean?
When electrons move, they're used.
When you're making.
Conduction means to touch. Things that conduct electricity because they're touching. Okay? Things that conduct heat because they touch the heat. Alright? Conduct means to touch. Alright? So when I'm charging an electroscope by conduction, that means I'm taking my negatively charged rod and I'm doing what to the electroscope?
Adding.
Rex.
Yeah.
I'm actually touching the electroscope. Okay? I'm touching the electroscope with a charged rod. That's called charging by conduction.
So it'll stay like that until
Okay.
you do something.
It'll stay like that until I
Remove them.
discharge.
So now what do you have? You have a.
I have a neutrally charged electroscope now.
But do you have electrons in your right
I have extra electrons in my body, but because I'm attached to the 4, they made their way out. It's not a ton of electrons, so I won't get like.
So now you're more negative.
I can zap Kyle at the end of the hour. Okay. Rex? There's actually little hooks on here that if I push them too far, the leaves will fall off. And that's not fun. So if you happen to get the opportunity to play with this electroscope, please don't see how much you can charge it. Because eventually you get enough charge that the leaves fly off, and then it takes me like a half an hour to get the glass out to put them back.
You
Okay?
have to rip it
So 30 seconds of cool for you guys, a half an hour work for me. Alright, and I almost cut myself every time. But alright, check this. So the charged electroscope. So what's happening? Alright? So what is happening?
It's shocking everybody.
Oh, hey. So we have our neutral electroscope, right? Plus, plus, minus, minus, plus, minus, plus, plus, minus, minus, plus, plus, minus, minus. Neutral electroscope, right?
Yeah.
Okay. When I bring a negatively charged rod close enough to where they touch, okay, what happens? The rod is really negatively charged, right? So the electrons on the rod, do they like being by each other? No. So what happens is, since this rod is an abundance of negative charge, the negative charges will leave and go onto the electroscope. So let's say that 4 negative charges go onto the electroscope. So if I have 4 negative charges go on the electroscope, that means I have 4 more negative charges. Now these negative charges will evenly distribute themselves because they still don't like each other. So, and as they evenly distribute, what happens to the leaves? They separate. So as they evenly distribute,
So are electrons electrolytes?
they separate. What'd you say?
Yeah. Are electrons electrolytes?
Electrolytes are anything that has a charge. So like electrolytes in Gatorade, those are ions. Because Gatorade is salty, has a lot of lithium and beryllium and sodium in it.
Makes you want to drink more.
Well, it's supposed to replenish things you lose. Alright, so back to the electroscope.
It tastes good.
Okay. I recently charged this electroscope. Right? Okay, the leaves are pretty spread apart, right?
Not really.
Okay, I know. Now, what's going to happen if I bring a positively charged rod near this electroscope? Okay. They get close together. Alright? Why do they get close together? Good! When I bring this positively charged rod next to this charged electroscope, the negative charges that are hanging out in the leaves, because they're all spreading out because we have more negatives than positives here, the negative charges in the leaves don't stay there. Where do they go? They run back up to the positive, which causes the leaves to do what? Go back together. So, in this picture up here, which you guys get to see double of now, right? These negatives down here, they leave and go back up here where the positive charge rod is. Okay? So that's what occurs. Right? Are there any questions about that? Does that make sense? Now, what would happen if I have a positively charged electroscope? Okay.
How you do that?
So let's take the same electroscope we had, but instead of charging it negatively, let's charge it positively.
You can't do that.
So plus plus minus minus plus minus plus plus minus minus plus plus minus minus. What creature of habit I know? All right. So if I bring a positive rod near this electroscope, and I touch the electroscope with a positive rod, what happens?
It takes away the negative.
Good. It takes away the negatives. Okay? The positives don't leave the rod. The negatives from the electroscope go where? To the rod. So these negatives from the electroscope will leave and go to the rod. So what we're left with then, we had 7 negatives. Now we only have 4 because 3 left, right?
Yeah.
So we have our 7 positives. 1, 2, 3, 4, 5, 6, 7. We have our 7 positives and only 4 negatives, right? So those 4 negatives will evenly distribute themselves because they still don't like each other. Right? Now these leaves are what kind of charge? Positively charged. So what do?
Push away.
They feel a force outward, and we get the same appearance as what type of charge?
Negative.
Negative charge. So can I tell by looking at an electroscope what charge it is?
No.
No. Positive doesn't mean in, negative doesn't mean out. Okay? All when leaves are out, what that means is that there is a charge. If I bring a charged object near this electroscope and the leaves get wider, that means it's the same charge as the electroscope. Right? If I bring a charge near the electroscope and the leaves get narrower, they get closer, that means it has an opposite charge. Okay? If I bring a neutral object near, what do you think happens?
Nothing.
No. Question.
Is it really?
I think, I mean, my inclination is nothing. Come on, just stop this. Alright, let's charge it. Okay. Discharged.
I think it's something we might
Okay.
I think it's something.
So now I'm stealing electrons from the electroscope. Not quite as successful as giving it electrons. Okay. So I stole some electrons. Neutral hand. Let's see what happens. Nothing. Let's try the negative.
No, it's not.
Yeah.
Let's be done.
Not yet. Almost.
5 minutes?
Equals out.
No, but in 5 minutes or whatever.
Where are you going?
Physics gods don't want us to learn.
Ah, there we go. Okay. So I bring the negative charge and leaves go close together, which tells me that the electroscope is positively charged. Let's discharge. Give some negative charge. Leaves are far apart. Neutral.
It's not working.
Yes.
Get closer.
Don't you touch it?
You got too many charges.
No,
Don't
it's
touch
just
it.
gonna be
No, if I touch it, it discharges. Okay. So it looks like, if anything, maybe a slight deflection,
No.
a slight change,
No.
Yeah.
Oh, okay.
Have somebody else.
Look,
a little wiggle.
I see.
Like a wobble.
Yeah.
Wobble, wobble.
If I touch it,
Why did you
Oh,
bring
they
like a
discharge.
water
Nah,
bottle?
a what?
What was this supposed to do?
I don't know. That's right. I think a neutral charge will have a slight displacement because the charge will recognize there's an opposite charge in your hand. They'll either move up or move down depending on what the charge of the scope is.
Are we gonna use those?
All right. Any
Are
questions?
we gonna demonstrate those and
Good
stuff?
lesson.
Any questions?
Now what the heck is that?
Yeah, let's play with those toys.
You can use those.
What's that one thing
Cool.
where it's like a